Thank you, everyone, for joining us for another Silicon Labs product podcast. We're extending our conversation on our Wi-Fi products. We're excited. We have some new products that we've introduced, so we want to make sure everybody knows the best parts about them. So I have Nick Dutton. Nick joined me again today. Thanks, Nick.
Hey, Kyle. How are you doing?
Good. So, as usual, what I've done is I've looked at the material that you provided to the team and also to the customers, and I just come up with some questions that I think might be asked by those people.
Okay.
So we're focusing right now on the WF200. You want to give a couple, the elevator pitch on what is exactly the WF200 and what does that provide to us?
Okay. Well, the WF200 is fundamentally it's our basic transceiver that's used in our Wi-Fi portfolio. It is only a transceiver. There is no MCU involved, and this gives us the opportunity to offer a flexible architecture that can be used with third-party MCUs, even large MCUs, small MCUs, that doesn't really matter. Or we can use it with our own MCUs.
What allows that? I mean, is there something inside of the WF200 that you guys put together that allows you to target either external MCUs or maybe our own MCU?
Yeah, basically what we did in our transceiver, the WF200, we brought the Mac into the product, which allows us to do a lot of the low-level functionality of Wi-Fi directly on the transceiver itself, allowing the network stack and so forth to exist externally on the host microcontroller. Now, bringing the Mac into the device, we also then split it so that we offer an upper and a lower Mac alternatives. The lower Mac is really designed for external RTOS, Linux type environments. So this gives us the opportunity to work with free RTOS. It gives us the opportunity to work with big A-class microcontrollers. It gives us the opportunity to do some corner case functionality such as enterprise security. This doesn't necessarily mean it's the lowest power solution because, of course, Linux devices tend to be a higher power device anyway. However, if you take the upper Mac implementation, then we are taking a lot more of the functionality off that microcontroller, allowing us to use things such as the Gecko family. The Gecko family is optimized for low power, as much sleep as we can get type applications. So battery powered products become something that this Wi-Fi chipset can support that many of the other Wi-Fi chipsets can't.
Okay, so you mentioned the external partners and free RTOS is some things. Are there other drivers or things that our team or customers should be aware that we provide? I mean,
yeah. So again, this is if we're using third-party MCUs or free RTOS or Linux or something like that. We fundamentally provide an open source driver that customers can use with their code running on those microcontrollers.
And has that been tested through, isn't there a consortium or a Wi-Fi plugfest type environment similar to Bluetooth?
In this aspect, that doesn't really matter. The plugfests tend to be how Wi-Fi devices work with each other. This is more about how we're working with an MCU.
Okay. All right. And because it's a transceiver, then that they need to work on their own. We wouldn't certify every permutation of MCU.
That's correct.
Wi-Fi chip.
That's correct. Now, we're not throwing this over the fence. We've done a lot of testing specifically with ST. Why ST? Well, the reason we've done that with ST is because ST has a pretty good grasp of the Wi-Fi market today. So we expect that most customers have got legacy code. We don't want to force them to change because that makes it harder for us to get in through the front door. If we instead can offer them the ability for them to use the MCUs that all their code are based upon, they can use us for their transceiver. That at least opens the door for future conversations to switch out that MCU.
Okay. Now you mentioned the low power. Obviously, if they want a low power application, maybe battery run or rechargeable batteries, they can leverage a low power MCU and partner it up with the transceiver. And that is obviously taking advantage of the MCU low power. Is there anything or a couple things that the WF200 has as far as low power things that benefit low power applications?
Certainly. So again, before we jump straight into that, we're really now talking about where we excel generally as a company. We're talking about low power, so this is a fantastic opportunity for the Gecko family to join the transceiver. But yes, you're absolutely correct. We have done a number of things in the radio itself to help lower the power. One of the best things we've done is we've actually increased our blocking performance. And that's important in Wi-Fi specifically because Wi-Fi is a dynamic protocol. So what Wi-Fi does is it evaluates, the congestion in the air and noise in the air, and in order to get the message through, it instructs the whole system to lower the data rate, which increases the likelihood of message delivery. The downside of lowering the data rate, of course, is that you're on the air longer, so you're using power more. So given our direction here is to be the lowest power solution, we want to avoid dropping that data throughput because we want to get on the air, get off the air, and get back to sleep. So by improving our RF performance, we can actually mask out that noise away from the Wi-Fi protocol, and the Wi-Fi protocol therefore doesn't have to lower the data rates. So our functionality in that respect, or our battery conservation, is vastly improved.
Okay. Does that have anything to do with the receive sensitivity? Just basic RF transmission specs that our part has? Is that
certainly if you look at all of our transceiver specs, of course we're trying to lead the field here, but it's not just sensitivity. The selectivity is a big aspect of that as well.
And that's like next channel, or next the interference with other channels, things like that. The true RF performance. Not just transmit and receive, but the ability to focus in on where it's centered.
That's right. To be fair, the terms selectivity and sensitivity sound very similar, but if you actually use them is the way they are deferred. Sensitivity is how sensitive are you? How good is your hearing? Selectivity, how well can you select what you're trying to listen to out of the noise? For many years I used to use an analogy of drinking at the bar. RF is just the same. So in an empty bar with nobody there, you can be the other side of the bar. You can talk to your friend at the bar at whatever speed you want and say, get me this drink. As soon as the crowd start piling in, you slow your speed down. You look at that person. You're really trying to select that person out the crowd, and it brings in all this concentration, which improves the RF performance. Now, of course, if you can mask out that noise, which is what we were talking about earlier, make all those people appear like they're not there, we can do things a lot better. We don't have to slow down. We don't really have to look at that person to read their lips.
That's great. Great analogy, Nick. So speaking about the performance of the radio, I read about the antenna diversity, and it's mentioned several times, but I didn't quite understand, maybe you have another analogy or maybe a better explanation so I can understand. How does that help the WF200?
Okay. Well, the antenna diversity is really a useful function to be able to work in the troughs of the RF performance, if you like. So if you've got two antennas, very polarized antennas, so what do I mean by that? If you've got an antenna which is upright, the RF signal, if you will, is going to go left and right. If you turn that antenna on the side, it's going to go up and down. Okay? So if you've got two antennas at 45 degrees to each other, then you're taking care of left, right, up and down. So you get rid of the bad parts in your environment because you cover a greater the environmental coverage is better. Now, This, of course, is even more important when when one of your devices is moving around. And so if you've got some sensor in your hand and you're walking across the room, you're moving in and out of these issues. So the whole time, off a single antenna, you're working with a Wi-Fi signal that's going to slow down, speed up. You're going to use reflections, and you're challenging the RF environment. Antenna diversity, however, is going to reduce the need to continually modify what you're doing, because it's just looking around a little bit better. Again, these are analogies that we're using to try and explain this, but that gives you some context of what antenna diversity brings.
And that'll be used at both the controller and at the devices?
No, that doesn't have to happen, actually. The reality is if one of them has it, then you're covered. If you're putting it on both sides, then you're evaluating packets on both sides, and maybe that's not needed.
Mm-hmm.
I don't know. I guess there's no harm, but it's not necessarily needed.
Great. Well, I appreciate those were the questions I had. I appreciate your time. We have some other topics we're going to touch on, and we'll have those in our other podcasts. Is there any place you always remind me to tell our listeners, where should they go to get more information about the Wi-Fi products?
Well, with the launch of the Wi-Fi family, we actually have our own Wi-Fi page now on siliconlabs.com. So if you just head through to the wireless sections, you'll see several buttons which address each of the technologies we have. Wi-Fi now has its own. All the information is in there.
Perfect. All right. Thanks, Nick.